So imagine for a second that a stainless steel needle, one that's barely thicker than a human hair, is piercing your skin.
Right?
And the moment it hits this very specific layer of deep tissue, the microscopic friction between that metal and your biological polymers literally strips away
Yeah,
electrons.
it creates a massive local charge,
Exactly. It generates this localized spark of like up to 6 volts, basically a literal microscopic lightning strike right inside your flesh.
which is wild to think about.
It is. And then your muscle violently twitches, and suddenly this chronic pain you had for a decade just poof,
It's
vanishes.
completely gone.
Right. And, we've all felt that mysterious release of physical tension, maybe during a deep stretch or a massage or dry needling, where the relief isn't just physical, it feels intensely emotional.
Oh, absolutely.
But for decades, medicine has kind of just written this off as basic mechanical loosening or like a simple nerve reflex.
Yeah, just brushing it aside, basically.
Right. But the stack of research we are tearing into for today's deep dive suggests something far, far more profound. We are talking about quantum biophysics, structured water, and this biological power grid that literally spans every millimeter of your body.
It's a total paradigm shift.
It really is. So today's deep dive is all about the undisputed, yet historically totally ignored, star of human anatomy, fascia.
And, it's really hard to overstate just how ignored it's been.
Oh, for sure.
I mean, if you look back at classical anatomical dissection, medical students were literally taught to just scrape the fascia away.
Wow, really? Just get rid of it?
Yeah. They treated it as, like, biological packing peanuts. It was viewed as this completely inert, passive wrapping paper whose only real job was to, keep your liver from rubbing against your ribs.
Right, or like keeping your bicep from fusing to your tricep.
Exactly. The baseline assumption was always that the muscles, the bones, and the brain, those were the hardware. And the fascia was just the cardboard box it all shipped in.
Which is such a wild oversight when you actually look at the math. I mean, going through the sources for this deep dive, we're talking about a continuous, three-dimensional living fabric that makes up, what, 20% of your body weight?
Yep, a full fifth of your mass.
Right, you don't just carry around 20% of your body weight in passive bubble wrap. It just doesn't make biological sense.
No, it really doesn't.
So if it's not just packaging, what is it actually doing? Like at a fundamental biological level?
Well, to understand what it's doing, you really have to look at its architecture first.
Yeah.
Because it's not just one uniform sheet, right?
Okay.
It's a highly specialized, multi-scale layered system. So let's start just beneath your skin. That's the superficial fascia.
Right, the stuff right under the surface.
Exactly. It blends with the adipose tissue,
Hmm.
the fat. But to call it just a fat layer is a massive disservice. This layer is actually a metabolic and endocrine powerhouse.
Wait, endocrine, like hormones?
Yes, exactly. It actively manages your thermoregulation, it stores metabolic water, and it acts as this primary conduit for your lymphatic and immune signaling.
Oh, wow.
It's basically the protective highway for all the neurovascular bundles traveling up to your skin.
So the superficial layer is essentially the interface between the outside world and our internal mechanics.
Precisely. But then, when you move deeper, you hit the deep fascia. Yeah. This is also called the musculoskeletal fascia.
Right, this is the tough stuff.
Yeah, this is the dense, fibrous tissue that tightly wraps your muscles and bones. So if you're looking at a microscopic cross-section, you'd see layers like the epimedial fascia, which encases individual muscles, and the aponeurotic fascia.
Aponeurotic, that's a big word. What's that look like?
They form these broad, sort of pearlescent sheets across large areas of the body. Think of it like your IT band in your leg.
Oh, yeah, the IT band. Everyone's got tight IT bands.
Right, or the thoracolumbar fascia in your lower back. This deep layer is specifically designed for heavy mechanical load transmission.
Got it. Okay.
And then finally, you have the visceral and neural fascia. These are the specialized sheaths that literally suspend your organs in your body cavities.
So they're holding everything in place inside.
Yeah, and they also enclose your entire nervous system.
Okay, so structurally, that makes total sense. We have superficial for metabolic interface, deep for mechanical force, and visceral for suspension.
You got it.
But, okay, here is where I need to stop you, because I read the notes for this deep dive, and the word quantum appears, like, a lot.
It does.
And I'm going to be honest, when I hear quantum biology, my pseudoscience alarm starts ringing pretty loud.
Which is totally fair. It's a healthy skepticism.
Right, because how do we get from a physical sheet of connective tissue to literal quantum mechanics?
Well, the physics here are actually rigorously documented, but we have to zoom way, way down. like into the interior of the cells that make up this fascial tissue,
Okay, so zooming in.
specifically to the cytoskeleton. The foundational theory here comes from Sir Roger Penrose, who won the Nobel Prize in Physics, and Stuart Hameroff.
Oh, the Penrose-Hameroff theory. Usually I see that brought up in debates about, like, where human consciousness comes from.
Exactly. It's the same theory. They propose that inside the cytoskeleton of our cells, there's this microfascial network made up of fluid-filled tubes. They're called microtubules.
Microtubules. But what do microtubules inside a cell have to do with the connective tissue of my back?
Everything, actually.
Hmm.
Because these microtubules aren't just structural scaffolding, they are optical and electrical cavities.
Wait, optical, like light.
Yes. Inside these hollow tubes, you have water molecules and electromagnetic fields interacting. Penrose and Hameroff theorized a dynamic called superradiance.
Super radiance. Okay, that sounds like a sci-fi weapon. What is actually radiating?
Right, so in quantum field theory, superradiance occurs when a group of atoms or molecules sync up their quantum states.
Synced up how?
Well, your body is naturally full of disordered, incoherent energy,
Hmm.
like thermal heat, ambient electromagnetic noise, just the chaotic vibration of molecules.
Just background biological noise.
Exactly. And the microtubules take that chaotic background energy, and because of their specific cylindrical geometry, they force it to cohere.
They organize it.
They transform that biological noise into highly coherent photons, light energy.
Wait, pause. Are you telling me that the inside of my cells is literally generating and transmitting laser light?
Yes, I am. They're called biophotons.
Biophotons, that's wild.
Fritz Albert Popp and other researchers actually demonstrated decades ago that living cells emit light. And this light is a primary mechanism for instantaneous cellular communication.
But how does that specifically tie back to fascia?
Because fascia is the only tissue that forms a continuous, uninterrupted 3D web throughout your entire body.
Oh, I see.
Because of this continuous web, these nonlinear quantum field effects influence the entire collagen matrix.
Hmm.
Your fascial collagen fibers are basically acting as a biological fiber optic network.
You're kidding, a fiber optic network.
Yeah, they're transmitting these biophotons at speeds that chemical nerve signaling could never, ever hope to match.
But wait, fiber optic cables work because they're made of perfectly clear manufactured glass. Fascia is, biological tissue, is full of water and proteins and stuff. So how does light travel through that without just scattering or being absorbed instantly?
That is the absolute genius of the system. And it comes down to the physical state of the water.
The water.
Yeah, the water inside your fascial matrix isn't the regular liquid water you drink from a tap. It is what we call structured water, which has been heavily researched by scientists like Gerald Pollack.
Okay, I think I've heard of this.
It's also known as exclusion zone or easy water.
Right, I've seen easy water mentioned in some alternative health circles. But let's break down the actual biophysics here. Why is it called an exclusion zone?
Well, when water meets a hydrophilic or water-loving surface, like the collagen proteins in your fascia, the H2O molecules actually change their structure.
Change how? Like they freeze?
Not quite freeze, but they arrange themselves into this tightly packed hexagonal crystalline lattice. The chemical formula actually shifts closer to H3O2.
Wow, okay.
And this lattice is so incredibly dense that it physically excludes dissolved solutes and protons, just pushing them away. Hence, the exclusion zone.
Oh, that makes sense.
But crucially for our fiber optic network, this crystalline water behaves as a semiconductor.
Okay, so it's not exactly a liquid, and it's not ice. It's essentially a liquid crystal.
Precisely. It's a liquid crystal. And because of this highly ordered crystalline structure, it allows for near instantaneous transmission of both biophotons, light, and electrical charge.
That is insane. How fast are we talking?
Studies suggest that information communicated through this liquid crystalline fascial network travels 3 to 10 times faster than the cellular action potentials of your traditional nervous system.
Wait, 3 to 10 times faster than my nerves?
Yeah.
So if I'm understanding this correctly, my nervous system is basically like a dial-up modem.
That's a good analogy.
Like, it's complex, it's reliable, but it has a physical speed limit because it relies on chemical neurotransmitters, physically crossing synapses.
Right, there's a biological lag.
But the fascia is this high-speed, biological, fiber optic broadband network that operates on quantum coherence.
That's a highly accurate way to visualize it. The traditional nervous system regulates and modulates very specific targets. But the fascial web, that's your primary system-wide information superhighway.
Okay, my mind is already kind of blown by the fiber optic angle, but networks need power. A fiber optic cable doesn't just light itself up.
Very true.
And the sources for this deep dive focus really heavily on fascia acting as a battery. So where is all this electricity coming from if it's not coming from the brain?
The electricity is actually coming from your own movement.
My movement.
Yeah, via the piezoelectric effect. This takes us back to some foundational research from the 1950s and 60s by these Japanese scientists, Fukada and Yasuda.
What did they find?
They discovered that when you mechanically deform biological tissues, they first proved it in bone and later in collagen and fascia, they literally generate an electrical charge.
Mechanical deformation, meaning like just stretching or squishing it.
Yeah. Exactly that. Compression, tension, or shear forces. When you bend a collagen fiber, the physical displacement of the molecules creates a separation of charge.
Oh.
You are literally generating electricity just by moving. The mechanical stress of you walking, breathing, or even just maintaining your posture against gravity, all of it generates continuous microvoltages across your fascial matrix.
So we are walking, breathing piezoelectric generators.
Exactly.
But generating a charge is one thing, right? Storing it is a whole other problem. You can't just have random electricity zapping around the body unchecked. How does the fascia actually capture this energy?
To understand the storage part, we need to map out the tissue, kind of like an electrical engineer would map a circuit board.
Oh, I like this. Okay.
Let's mentally draw a standard RC circuit. That's a resistor-capacitor circuit.
All right, listeners, picture a circuit diagram in your head. We need a resistor, a capacitor, and a power load. Where are these parts in my deep tissue?
So the demand, or the load in the circuit, is your cellular metabolism. Your mitochondria are constantly doing the respiratory work, which requires energy.
Okay, load is mitochondria.
Right. Then, those microtubular networks we talked about earlier, they act as the resistor, kind of regulating the flow.
Resistor.
Check. And the capacitor.
Right.
That is the multi-layered stacking architecture of your deep fascia itself.
The fascia is the capacitor.
Yeah, because in a circuit, when there is no immediate demand from the load, electrons don't just disappear. They flow into the capacitor to be stored as potential energy.
Our sources specifically call this the fascial capacitor model, and they compare human connective tissue to an MLCC, a multi-layer ceramic capacitor.
Yes.
Now, I know what a capacitor does inside my smartphone, but structurally, how is biological tissue acting like a ceramic electronic component? I mean, there are no metal pleats in my back.
Well, the thing is, you don't actually need metal. You just need alternating layers of conductivity and insulation.
Oh.
A ceramic capacitor stores charge by sandwiching a layer of insulating material, which we call a dielectric, between two layers of conductive material.
Right, standard capacitor design.
And if we look at the histological architecture of human aponeurotic deep fascia, it perfectly mimics this exact design.
Really?
Perfectly. There's brilliant research by the Stecco group in Italy that revealed this deep fascia is built of 2 to 3 sublayers of densely packed type I collagen fibers.
And how thick are those layers?
They're quite robust, about 277 micrometers thick, and they cross each other at roughly 78-degree angles.
And because that collagen is surrounded by that highly ordered easy water we talked about, it acts as a semiconductor.
Exactly.
So those thick collagen bundles, those are our conductive plates. They're the electrodes.
You've got it. That's the conductive part.
Right.
But now, for a capacitor to actually work, those conductive plates cannot touch each other.
Right, or just short circuits.
Exactly. They must be separated by an insulator. So sandwiched between these thick collagen electrodes is a much thinner layer, about 44 micrometers thick, of loose connective tissue.
What's in that thin layer?
It's primarily this viscous gel-like ground substance that's really rich in glycans or GAGAs. And the absolute star player in this layer is hyaluronic acid.
Wait, hold on. Hyaluronic acid, I know that from like skincare commercials. People inject it into their faces or use expensive serums because it plumps the skin, right?
Right, it's famous in dermatology. It plumps the skin because a single molecule of hyaluronic acid can bind a massive amount of water.
Okay.
But deep inside your fascia, its biophysical role is entirely different. This highly hydrated hyaluronic acid layer acts as the dielectric, is the insulator.
Oh, wow.
It physically prevents the electrical charge in the top collagen layer from jumping down to the bottom collagen layer.
So who manages this? Like, does the body just passively leak hyaluronic acid between these layers and hope for the best?
Not at all. It's a highly regulated process run by a specialized type of cell called a fasciocyte.
A fasciocyte?
Yeah. The fasciocyte's entire biological imperative is to secrete hyaluronic acid to maintain this dielectric layer.
So it's like a little mechanic making sure the insulator is intact?
Essentially, yes. It ensures the collagen sheets stay separated, which allows them to glide smoothly over one another when you move, while simultaneously maintaining the electrical insulating capacity of the capacitor.
Okay, let me just stop and make sure I'm visualizing this correctly because this is wild. You're saying the deep tissue in my back or my legs is stacked exactly like the battery capacitor inside a Tesla or my smartphone.
Yep, the exact same architecture.
The thick collagen acts as the conductive metal plates, the hyaluronic acid is the chemical insulator, and every time I take a step or take a breath, the piezoelectric effect cranks the generator, filling those collagen plates with electrical charge.
That is the literal, exact biophysical reality of your anatomy.
That is absolutely incredible, but, it raises a huge question for me, a question of why.
The evolutionary question.
Exactly. Biology doesn't do things by accident. Evolution is fundamentally lazy, right? It doesn't build complex, high-speed quantum capacitors just for fun.
No, it builds them for survival.
Right. So why would early human biology require us to store up latent electrical charge in our connective tissue?
It all comes down to survival and the adaptive stress response.
Mm-hmm.
Think about the environment of our ancestors.
Okay, hunting on the savannah.
Right. Survival out there often meant the difference of a microsecond. You had to react instantly with explosive power to evade a predator or to make a kill.
You couldn't afford to be slow.
Exactly. And if you rely solely on your brain sending a chemical signal down a motor nerve to tell a muscle to contract, there's a built-in lag time.
It's fast, but not instant.
It's milliseconds, sure. But in nature, that lag can be lethal.
So the fascia acts as like a biological hack to bypass that lag?
Exactly. Because early humans were constantly moving. They were walking miles a day, running, climbing.
Okay.
They subjected their fascia to continuous low-amplitude mechanical loading.
They were constantly turning the crank on the generator.
Yes. This constant piezoelectric generation created a persistent, latent electrical field that got stored within the fascial capacitors.
So they were basically walking around fully charged up all the time.
Fully charged. And this stored potential energy allowed for immediate elastic recoil.
Oh, like a spring.
Exactly like a spring. When a hunter needed to throw a spear or jump out of the way, the power didn't just come from concentric muscle contraction.
Where did it come from?
It came from the explosive release of that elastic potential energy stored in the highly charged fascial spring. It provided a critical, immediate stress advantage. The tissue was quite literally primed with bioelectricity.
Okay, that makes perfect sense for a hunter-gatherer sprinting across a savanna, trying not to get eaten by a saber-toothed tiger.
Sure.
But let's fast forward to today, because I am not hunting. I'm sitting at a desk, staring at a monitor, slumped over a keyboard, and I'm just stressed about emails for 9 hours a day.
Welcome to modern life.
Right. I'm not discharging that energy by throwing a spear. What happens to my biological battery? Does it just, overcharge?
You are hitting on the absolute core problem of modern musculoskeletal health. Yes, it overcharges, and the architecture of the fascia physically freezes up.
It freezes.
We call this process fascial densification. When your fascial system is subjected to chronic mechanical stress, and that absolutely includes the postural overload of sitting statically at a desk all day, the biological system gets totally confused.
Why does it get confused?
Well, those fasciocyte cells we mentioned, they sense the continuous low-grade shear stress of your bad posture. They think there's a problem, so they overreact. They start pumping out massive amounts of hyaluronic acid.
So it tries to add more lubricant to fix the tension.
Exactly, but it totally backfires. Because you aren't moving through a full range of motion, the hyaluronic acid doesn't spread out.
It has nowhere to go.
Right. Instead, the molecules hyperaggregate. They cross-link with each other and become highly concentrated. That smooth, lubricating gel turns into a dense, sticky glue.
So my insulating layer is now glued solid. What does that do to the battery aspect?
From an electrical engineering standpoint, this densification drastically increases the local insulating capacity of that dielectric layer.
Meaning it's too good of an insulator now.
Yes. In physics terms, you are extending the RC time constant by orders of magnitude. The electrical charge that your body naturally generates, which is supposed to flow, do work, and dissipate, gets trapped.
Battery can't discharge.
Right. You develop a massive, steady-state electric field where there shouldn't be one. The collagen plates are holding maximum voltage, but the densified hyaluronic acid won't let it go.
And how does that feel to me, the person?
The tissues physically adhere to one another, preventing that healthy glide, which you consciously register as just deep chronic stiffness in your neck or back.
Wow. But, it's not just physical stiffness, right? We all know fascia is deeply tied to how our body perceives itself. The psychological component here is huge.
Oh, it's massive.
The sources for this deep dive point out that fascia is packed with 250 million nerve endings.
Yep, 250 million.
If my fascia is acting as a frozen, overcharged hard drive, what is that doing to my brain?
It is basically shouting at your brain constantly. The ratio of nerves in the fascia is just astounding. In certain regions, the sensory neurons outnumber the motor neurons by a ratio of 9 to 1.
9 to 1.
Yeah. Fascia is primarily a sensory organ. It is actually the largest organ of interoception in the human body.
Okay, interoception. For you listening, we all know interoception is basically how the brain tracks the internal state of the body, like your heart rate, your respiration, that literal gut feeling.
Right, it's the physical baseline for our emotions.
So how does this trapped electrical field disrupt that emotional baseline?
Imagine what happens when you experience chronic psychological stress, or maybe a distinct emotional trauma. Your autonomic nervous system shifts into sympathetic overdrive, the classic fight-or-flight state.
Okay, adrenaline, tension.
Exactly. These systemic alarm bells trigger the fascial matrix to physically contract and stiffen as a protective measure. Blood vessels within the tissue constrict, creating a state of localized ischemia, meaning the tissue is starved of oxygen, a state called hypoxia.
So the emotional stress literally suffocates the physical tissue.
It suffocates it,
Mm.
and it locks that trapped electric field in place. Now think about those 250 million sensory nerve endings.
Right.
They are now embedded in a tissue that is glued together, oxygen-starved, and buzzing with a trapped, steady-state high voltage.
That sounds agonizing for a nerve.
It is. Those nerves are agonized and overstimulated. They begin firing erroneous, chaotic signals back up the spinal cord to the brain. Researchers actually call this interoceptive noise.
Wow, interoceptive noise. So the brain is sitting up in the skull trying to figure out how the body is doing, and all it hears is this screaming static coming from the fascia.
Exactly. And because the brain relies on those interoceptive signals to construct your conscious emotional reality, it misinterprets this constant physical tension and electrical static as a continuous, existential emotional threat.
It's a physical feedback loop for anxiety.
A devastating one, yeah.
Uh-huh.
The brain feels the fascial static and registers anxiety. The conscious feeling of anxiety triggers the sympathetic nervous system to stiffen the fascia even further, which creates more static.
It just feeds itself.
Right. This loop is deeply implicated in the physical pathology of chronic depression, PTSD, and generalized anxiety. And furthermore, remember that the superficial fascia acts as a conduit for hormonal transport.
Oh, right. We talked about that earlier.
It supports the transmission of vital neurotransmitters like serotonin, dopamine, and GABA. When your fascial layers are densified, glued down, and electrically jammed, this biochemical exchange is physically bottlenecked.
So I literally cannot transport the molecules of happiness and relaxation efficiently.
You literally cannot. The physical structure is preventing it.
It gives a terrifyingly literal meaning to the phrase, the body keeps the score. The fascia is physically archiving your psychological trauma in the form of trapped voltage and cross-linked polymers.
That is exactly what is happening.
Which brings us to, I think, the most practical question of this entire deep dive. How do we reboot the hard drive?
Right. How do we fix it?
If the battery is jammed, the hyaluronic acid is acting like superglue, and the nervous system is trapped in a feedback loop. How do medical interventions actually trigger a reset? I know we have extensive data here on dry needling and acupuncture, but I'm struggling with the mechanics.
How a needle fixes a quantum electrical jam.
Yes. How does poking a tiny metal stick into a muscle do anything at that level?
Well, to appreciate how revolutionary this new understanding is, we first have to look at what the medical establishment believed for the last 50 years.
Okay, what was the old theory?
If a doctor or a physical therapist put a needle into a tight muscle, and the muscle gave a violent, involuntary twitch, what we call the local twitch response, the accepted explanation was the integrated trigger point hypothesis.
Right, the idea that a trigger point is just a knotted muscle fiber. What was the exact mechanism they claimed was happening to cause the twitch?
The classical theory claimed that the issue was a dysfunctional motor end plate.
A motor end plate? What's that?
The motor end plate is the exact junction where a motor nerve connects to a muscle fiber. The theory was that due to stress or injury, this junction started leaking a neurotransmitter called acetylcholine.
And that leakage caused a problem.
Yeah, they thought the leakage kept that tiny section of muscle locked in a permanent microspasm. When the practitioner inserted the needle, it was believed the metal physically disrupted that specific leaky nerve muscle junction, essentially resetting it.
I mean, that sounds perfectly reasonable. Why is it wrong?
Because the imaging technology finally caught up to the practice. There's a recent, groundbreaking retrospective video analysis that utilized high-resolution, ultrasound-guided fascial hydrorelease.
Okay, so they could actually see what was happening inside in real time.
Exactly. They recorded 89 evaluable local twitch responses, LTRs. When the researchers analyzed the ultrasound video frame by frame, they found something that completely dismantled the motor end plate theory.
What did they see?
100% of those 89 twitches occurred in the stacking fascia.
Wait, 100%. They didn't happen in the muscle fiber at all.
Not at all.
They happened in the capacitor layers.
Entirely in the fascial layers. And critically, these twitches occurred at anatomical sites that were completely incompatible with direct motor end plate excitation.
Meaning there were no end plates nearby.
Right. They were happening deep in intermuscular fascia or in ligamentous layers that were sometimes centimeters away from the nearest motor end plate. The twitch is absolutely not coming from a leaky neuromuscular junction. It is coming from the fascia itself.
Okay, let's pause and look at the physics there. If the needle isn't hitting a nerve junction to reset it, why does the muscle violently twitch just because a needle touched the fascia?
This is where the fascial capacitor model goes from being a theoretical concept to a clinical reality.
Yeah.
Think about the material properties of an acupuncture or drawing needle.
Okay, it's solid stainless steel.
Right. It is a highly conductive metal object. When that metal needle pierces through the densified tissue, it is crossing through the thick collagen plates and the trapped hyaluronic acid dielectric.
Oh.
The needle acts as a literal, physical short circuit across the multi-layered biological capacitor.
It bridges the gap, it connects the positive and negative plates, but, and maybe I'm underestimating biology here, is there genuinely enough voltage stored in human connective tissue to cause a macro-level muscle to violently spasm? Like, are we talking about real, measurable electricity here?
We are talking about highly significant voltage. Let's do the math provided in the biophysics papers we're looking at.
Let's do it.
In a normal, resting steady state, the bulk voltage across these fascial layers is tiny, about 0.4 millivolts.
Okay, tiny.
When a doctor injects fluid into the fascia during a hydrorelease procedure, that transient pressure pulse increases the piezoelectric charge to about 25 millivolts.
Still pretty small, though.
But that is just the bulk tissue voltage. We have to account for the geometry of the needle itself.
Because the needle is pointed.
Exactly. In electromagnetism, electric fields concentrate at sharp points. Because the tip of a dry needle is microscopically sharp, it concentrates the ambient electric field exponentially.
Exponentially.
The voltage is amplified roughly 30 to 90 times. This means that at the exact microscopic point of the needle tip, you are hitting an electrical field of around 1 full volt.
1 volt inside a single microscopic point in the tissue.
Yes, and the dynamics get even more intense when you factor in the triboelectric effect.
I've seen that term in the notes, triboelectricity. That's contact electrification, right? Like rubbing a balloon on your hair to create static electricity?
Precisely. It's the generation of charge through friction between two different materials. A recent landmark study by Yu Yang and his colleagues investigated what happens when you rub a stainless steel acupuncture needle against biological polymers.
What did they find?
They found that just the microscopic friction of inserting and rotating the needle against the collagen and hyaluronic acid physically strips electrons away. This contact electrification generates a massive local potential difference of plus or minus 6 volts.
6 volts? That's equivalent to like 4 AA batteries just discharging at the tip of the needle.
It is a massive electrical discharge at the cellular level. When that short circuit happens, that sudden high voltage spike acts on the voltage-sensitive ion channels of the free nerve endings embedded in the fascia.
The ones that were screaming the interoceptive noise.
Exactly. It fires a massive afferent signal up to the spinal cord, and the spinal cord instantly reflexes back down to the motor neurons, causing the muscle to violently contract. That is your local twitch response.
Wow.
It is the biological equivalent of a lightning strike.
Okay, that is just astonishing. The spark perfectly explains the twitch. It explains why it feels like a literal electric shock when the needle hits the right spot.
Yep.
But here is the piece of the puzzle I'm still missing. Discharging a capacitor takes a fraction of a second, right? The spark happens, the muscle twitches, and it's over.
Right.
But patients get off the table, and their chronic back pain is gone for months. How does a 1-second electrical spark translate to long-term tissue healing? Like, why doesn't the pain just come right back?
To understand the lasting relief, we have to separate the healing process into two distinct timelines. Phase 1 is the immediate electrical reset, and Phase 2 is the long-term genetic reset.
Okay, walk me through phase one first.
Phase 1 is the spike. The moment the needle short-circuits the fascia, the trapped, steady-state electrical field completely collapses.
The battery is drained.
Exactly. Remember that this trapped field was the source of the interoceptive noise. It was constantly agonizing those 250 million sensory nerves. The millisecond that field drops to zero, the persistent electrical driver of the pain is gone. The static just goes silent.
That makes sense.
This perfectly explains why patients report profound, immediate pain relief while still on the treatment table, long before any chemical or physical healing could possibly take place.
So phase one is like hitting Ctrl-Alt-Delete. You force quit the frozen program and the processor immediately drops to zero.
Perfect analogy.
But what stops the program from just freezing up again the next day? If the tissue is still dense and sticky, won't it just recharge and jam again?
That is exactly where Phase 2 takes over, the long-term mechanoepigenetic reset. And this is arguably the most fascinating biology we'll discuss today.
I am ready.
It relies on a process called mechanotransduction, specifically a pathway called yapetazi.
Yapetazi. I am begging you to explain that step by step, because how does a mechanical poke change my genetics?
Let's follow the journey of the cell. YAP and TAZ are mechanosensitive proteins that live inside the cytoplasm of your cells.
Okay.
They're basically mechanical messengers. When your fascial matrix is densified and stiff, the cell membrane is physically stretched tight. The cell literally feels that mechanical tension through its cytoskeleton.
It feels the pulling.
Yes. This tension acts as a signal, telling the YAP and TAZ proteins to detach from the cytoplasm, migrate through the nuclear envelope, and actually enter the nucleus of the cell where your DNA is stored.
So physical stiffness forces these messenger proteins to invade the nucleus. What do they do once they are in there?
They act as transcription coactivators. They bind to your DNA and they alter your gene expression.
They change the code.
They activate specific genes known as CTGF and ANKRD1. These genes instruct the cell to produce more fibrotic material, more stiff collagen, and more sticky hyaluronic acid.
Wait, so the physical tension literally programs your DNA to keep the tissue stiff?
Yes. The cell believes it needs to reinforce itself to survive the stress. This creates a long-term, self-sustaining mechanical memory of the trauma. The stiffness literally creates more stiffness at a genetic level.
That is a terrifying biological trap. How do we break it?
With mechanical disruption. When the practitioner repeatedly pistons the needle or injects fluid during a fascial hydrorelease, they are physically shearing those fascial layers.
Tearing the glue.
Exactly. They are tearing apart the cross-linked hyaluronic acid molecules. The tissue instantly softens, and the cell membrane relaxes.
And so the mechanotransduction reverses.
Instantly.
Yeah.
The moment the cell feels that the mechanical tension is gone, the signal stops. The YAPTC proteins deactivate, they detach from the DNA, and they're expelled back out of the nucleus into the cytoplasm.
Wow.
The fibrotic genes switch off, the gene expression returns to a healthy baseline state. The fasciocytes stop overproducing that sticky HA and return to secreting normal lubricating fluid.
That is unbelievable.
You haven't just loosened the tissue. You have literally wiped the mechanical memory of the trauma from the cell's genetic code. You have reinstalled the operating system.
It is brilliant. The electric shock silences the nerve pain immediately, and the mechanical shearing rewrites the genetic code so the tissue stays healthy long term.
That's the 1-2 punch.
But this brings up a vital point about the scientific method. This is an incredibly elegant hypothesis. The math works, the biology works. But how do you prove it? Like, how do you prove empirically inside a living human being that this electricity is coming from the fascial capacitor and not a nerve?
The clinical trials being designed right now are just ingenious. Researchers are setting up protocols utilizing what they call insulating needle CA recording. CA stands for spontaneous electrical activity.
How does an insulated needle help prove anything?
Well, they coat the entire shaft of the needle in an insulating polymer, leaving only the microscopic metal tip exposed.
Okay, so the sides don't conduct.
Right. And using ultrasound guidance, they can precisely drive this needle directly into the densified hyaluronic acid layers of the stacking fascia, deliberately navigating far, far away from any motor end plates.
Okay.
The needle is attached to highly sensitive electromyography recording equipment.
So they are using the needle not just to trigger the twitch, but as a literal electrode to record the tissue's internal voltage at the exact moment of the twitch.
Exactly. If they record a massive electrical spike,
Mm.
the SEA originating purely from the fascia layer, and observe that electrical field completely collapse the exact millisecond the muscle twitches,
Hmm.
it will be the smoking gun.
It would be undeniable.
It will definitively, empirically prove that human fascia acts as an electrical capacitor, permanently debunking the 50-year-old motor end plate theory.
That research is going to turn physical therapy and sports medicine entirely upside down. It's so exciting. But, I want to zoom out from the clinical setting for a minute
Yeah.
because most of the people listening to this deep dive right now are not physical therapists or doctors. And I really don't want the takeaway here to be go get stabbed with a needle every time you feel stressed.
Definitely not.
How can you, the listener, apply this quantum capacitance model to your daily life? How do we maintain our own battery?
The beauty of understanding the biophysics is that it empowers you to take control of it yourself. You don't need a needle to manage this system. This brings us to the concept of recharging the battery and restoring resonance naturally.
Okay, how do we do that?
The key is understanding that mechanical stress modulates the bioelectric capacity of your deep tissue. But, and this is crucial, it has to be the right kind of mechanical stress.
Right, because sitting at a desk all day is mechanical stress, but that just glues the system shut. What kind of movement actually clears the system?
Practices that involve slow, sustained, multiplanar tension. Things like Qigong, Tai Chi, and specific styles of yoga.
Why go specifically?
If you look at the mechanics of Qigong, for example, it isn't just about stretching a single hamstring.
Hmm.
It involves slow, continuous loading, deep diaphragmatic breathing, and mindful whole body integration.
So you're not just pulling on the end points of a muscle, you're actively shearing the entire fascial web.
Exactly. This type of slow, sustained mechanical shearing does two things perfectly. First, it generates healthy, low-amplitude piezoelectric currents that flow evenly through the tissue.
Charging the battery smoothly.
Yes, and second, the physical glide actively pumps fluid through the fascial capacitors, physically breaking up the hyperaggregated hyaluronic acid.
Mm.
You're simultaneously charging the battery and preventing the dielectric layer from turning into glue.
It's fascinating that you specifically mentioned Qigong and Tai Chi because when we talk about energy flowing through the body in traditional Eastern medicine, they use the term qi.
They do.
And they talk about mapping the body via meridians. And Western science has historically scoffed at this because, they couldn't find a key vessel during an autopsy. Does this new fascial research finally align with those ancient concepts?
The overlap is frankly undeniable at this point. Leading fascial researchers have actually mapped the meridian lines of traditional Chinese medicine and found that they correspond almost exactly with the body's primary fascial planes.
Wait, really? Like perfectly mapped?
Almost exactly. For example, what TCM calls the bladder meridian traces the exact anatomical path of what we now call the superficial back line of fascia. The deep front line of fascia aligns flawlessly with the kidney and liver meridians.
So when ancient practitioners were talking about blockages in the flow of qi, they weren't talking about magic.
No, they were describing a biophysical reality. A blockage of qi can now be scientifically understood as the impedance of bioelectricity and biophotons.
The battery jam.
Exactly. It is the densification of the hyaluronic acid trapping the electrical field, which prevents the structured EZ water and the collagen matrix from conducting signals. When you move the body through Qigong or yoga, you are literally restoring normal fascial electrical conductivity. You are clearing that interoceptive noise.
You are getting the fiber optic network firing on all cylinders again.
Yes, and that brings us all the way back to the quantum level. It restores quantum resonance. We discussed earlier that the nonlinear quantum field effects, the superradiance of the biophotons, rely entirely on structural coherence.
Right.
When your fascia is hydrated, when the layers glide smoothly, and when the electrical field is balanced, those quantum signals transmit flawlessly across the entire body. The mind-body connection isn't some airy philosophical metaphor.
It's physical.
It is a literal, physical, high-speed communication network running through your connective tissue.
Wow. I want to take a second to just synthesize the sheer scale of the journey we've been on today, because it's huge.
It really is.
We started by looking at fascia the way old textbooks did, as inert packing peanuts, just biological bubble wrap. But by digging deeply into the biophysics, we've revealed it as a multi-scale, quantum biological, piezoelectric capacitor.
Which is a mouthful, but accurate.
Right. We learned how the dense collagen plates and hyaluronic acid insulator stack exactly like an electronic battery, capturing the electrical charge generated by our every movement. We saw how evolutionary survival adaptations, like the need for explosive, snored energy, can backfire in our modern sedentary lives.
causing that battery to overcharge and freeze.
Exactly, trapping our emotional trauma in a physical matrix and screaming interoceptive noise at our anxious brains.
And we explored the exact mechanics of how to fix it, too. We saw how the friction of a tiny metal needle can act as a biological short circuit, generating up to 6 volts of electricity, creating a micro lightning strike that collapses that trapped field, causing an instant muscle twitch.
And then the phase 2 reset.
Right, we walked through how that mechanical shearing triggers a deep epigenetic reset via the IAP-TAZ pathway, literally physically rewriting the mechanical memory of the cell.
So, to you, the listener, the next time you hold a deep stretch, or you take a deep, expansive breath, or you feel that sudden emotional release of tension in your shoulders, I want you to remember what is actually happening under your skin.
It's incredible to think about.
You are engaged in a constant, high-speed electrical dialogue within your own connective tissue. Your daily movements, your posture, and your hydration are actively managing a liquid, crystalline, quantum supercomputer.
And I actually want to leave you with one final, deeply provocative thought to explore on your own.
Ooh, let's hear it.
It's a concept that builds on everything we've unpacked today, yet pushes the boundaries of modern science even further. If our fascial web processes information at the speed of light using biophotons, if it acts as a liquid crystalline semiconductor, if it literally stores the physical memory of our emotional trauma, and if this continuous glowing web physically touches every single cell, every organ, and every nerve in your entire body,
Yeah.
could human consciousness itself be seated not just inside the neurons of the brain, but distributed throughout the vast electrical quantum web of the fascial system?
Wow. Now that is a thought to take with you. The cardboard box wasn't just the hardware. It might actually be the mind itself. Thank you so much for joining us on this deep dive. Keep moving, keep shearing those fascial layers, keep charging that battery, and we'll see you next time.